Okay. Today is the last meeting. The idea is to sum up everything, the most important thing. But in any case, everything in terms of topics. In any case, so we have an idea what in the examination can appear. Okay, in any case, believe me, in the sense, try to do at home also, how possible to say, yeah, the topic of free and false answer, of course, uh, will be present in the examination. Okay, look at this. What I can consider today in order to show you again, because we have seen many things, uh, this topic. Let me consider this. You have an object which consists of a mass m, and we have here it is. I think it is, no? I don't think so that we can improve. I can just focus. I don't. Do you know some options which allow to? I don't know how we can do. If you are able to do, I don't know any. I know with power with the presentation, but if you are able to help me, normally I didn't do any. I don't know any options because you see it's too small. But how I can enlarge, I don't know. If you know, you can come here to help me. Do you know the option? Probably so, but I don't know if it's better, no? Because it's a little bit better, but then I have to be careful because it is better now. But if you know, if you can manage here, but okay, we have a mass, a bar, no? We have a robot. You say, but we've never seen a robot. We will see that we have seen a robot. Why we have seen a robot? We have seen because for us, the robot is not modeled. It's modeled just what happens at the end effector of the robot. Now, why I am telling you today about that? Because, of course, in the exam, I will clarify eventually. No, if it happens, if appears something like that, I will clarify what I intend with the robot. I do remember the aerostat system. I don't remember which kind of example I did this semester, but I tried nevertheless during the semester to sketch a real situation. But of course, for the examination, we will see that the robot is not relevant in the sense, but you can imagine that the phenomenon which I want to analyze could be sketched with a robot, with the aerostat system. You remember the aerostat system? Or the active suspensions, you remember something like that? I don't remember. During the semester, I tried also to connect this dynamical system with some possible real scenario. Look, what do we want to do here? I have a mass m. I have a friction TV, friction parameter. Yeah, and then in the exam I will orient the system. You remember the concept orient the system. Everything you can find directly in the text of the exam. For instance, if I try to squeeze in sets, or to crash, if you like, this means I will fix in a positive direction, let me say Z. And then I will give you set of t position of what? Of the mass. Of the mass which I want to manipulate. Let me say manipulate. This is a manipulator. And z derivative, or the z dot velocity of the moving mass in the sets. Also here, if you like, moving mass, position, moving mass is better. Because the mass will move somehow. Now, really, the problem, as I told you during the semester, is quite complex if you consider the form of the mass, if you consider its plasticity as a material characteristics. We don't do that. No? We analyze just the movement of a mass concentrated in one point, in the center of mass. Do you remember this? I told you a lot. Let me go ahead of the position of the moving mass. Position of the moving mass. Question. The question you can question me. To organize this meeting, this is exactly to have the possibility to ask me, because otherwise I can upload the material is ready. No? Exactly. First question. Of course, in the exam you will have a list of questions, but here, first question. Please indicate the states and justify why this is. You indicate this is how we can formulate. Possible states. We know what the state are. Now I will repeat. States of the system. I don't need here to clarify it many things, because we know what I intend. And please justify. Let me say the choice. In the exam, I try to formulate it a bit better, but it's clear what I intend. Yeah, answer. Let me say question 1, Q1. Typically in the material you can find Q1 question 1. No? We answer directly. No? Response 1 or the answer 1. Set of t. We can see here position. Basically, this question is almost already answered in the data. Set derivative velocity. Why this choice or this indication? Because the position reflects the work, which is an energy. The velocity reflects the kinetic energy. Let me write in this form. Set reflect the work. Set dot reflect the kinetic energy. No? You remember this correspondence between states and energy. Here we have the movement. This means we have the work, which is an energy. And then because of the movement and the kinetic energy, it's set and set dot. Now, Question number 2. Build the model of the system of the system. You know, the system. I will write in the exam something better in the system represented in figure 1. No, but it's clear. We have just one system. Build the model of the given system. Let me say so. Given means as I told you, free and fourth answer topic, free and fourth, we will be. Now, this exercise really sum up many things. Concept of state, concept of the model, but at the end we will see, we will end up in my original idea. Because at the end, when we have a model, of course, when we have a model, we have differential equations. I can formulate a question related to the free and fourth answer. Build a model in the sense what we have seen, a mathematical model. Again, you remember, also the scheme is in a model. It's a graphical model. It's intended a mathematical model. Clear? Should I write? No, it's clear. I try to speed up, otherwise. Anyway, it's in a summary. It's not exactly in a lecture, but you can find, if you remember, everything already in my style. Okay. Let me write mathematical model so it's more clear. A mathematical model, but we will see that we have one mathematical model because the data which I indicated here. Mathematical model. Of the given system. Excuse me for this, but it's clear. The mathematical model. Okay. Response, try or answer. Look. If you look at the system, let me in this sense give you another element which you need in order. I mean, I can in any case build here the mathematical model with this element here, but of course later speaking about fourth answer, I have to consider an force which came or that comes from the robot. This means let me indicate directly now. Let me indicate directly now. Let me write here. I mean, the model can be also built with this element here, but let me introduce also the element which you need later also for the free and fourth answer, in which we consider an input force, a motoric force in the sense f of t, with, it could be that in the exam you will find f of t in the data, no, motoric force, with positive direction towards z. What I intend. Z of t. Intended this. F of t is positive in this direction. Moreover, also this could be that you find in the text. Moreover, the friction force Fr of t equals kV multiplied z derivative. I will read it for you. Build a mathematical model of the system here, in which I introduce directly now in order to be ready for the next questions. F of t is in a positive direction, as in a force, no? The input force, with positive direction toward z of t. In the example, you will find directly the scheme with all elements. For the model, basically, we don't need f of t because the model can be built also for the free answer. Do you remember? The free answer needs a model, in this case, without input, no? Without f of t. But let me repeat also this concept here, which I need to put the f of t with its direction, positive direction. And of course, I have to specify how I will consider the model of the friction. About the friction, I told you during the semester a lot of time. Could be also nonlinear, but I didn't do many things about the nonlinear systems. Just an idea yesterday and the last two lectures. This means we will consider also the exam. Let me say, at least in this context here, this example here, which could be also a possible question for the exam. Okay, answer 2. Response number 2. Yeah, Newton balance. M, the mass, multiply z dot, the acceleration. You remember in gymnasium. Sum of the forces acting on the system. Easy, huh? Now, why I started from 1 until 2? Because you have just 2 forces. Motor force, which is also indicated here, and the friction force. We don't see in this context here all the forces. This means now explicitly means m multiply the acceleration equal what? Extremely easy. F of t minus y minus. I told you during the semester many times, because the friction is always against the movement. Against the movement means this. Minus something is the coefficient. This moment, it's extremely easy. It's a linear model of the friction force. This basically is the model. Build the model is already somehow answered. This is the mathematical model. Ready? Easy. If the question is build a mathematical model, 2 sentences. Or if you don't want to repeat the background, directly the Newton. Probably you have seen in technical mechanics, I don't know where. Also by me in actuator, I don't remember what, but from gymnasium. Mass multiply the acceleration equals the sum of the forces acting on the object which I considering in the system. Ready? Easy? Yeah. Question number 3. Build the model, the mathematical model, in state space structure. Let me write. Please pay attention. Here, the key word is state, space, structure, format, let me say structure. The key word is this. It could be that I will give you an indication. I don't know if in the form example, in the data sheet, or in the text. Which one? Exactly what this is, because it could be that this moment you don't remember. Huh? This means it's extremely easy to answer. Which is the indication? You remember this? Now we will see what exactly this is. Huh? This is the general indication. We will see that U of t is our input. Our input is f of t. Remember, input force. This is the general indication which you can find in any book, during the lecture, during the semester. I don't know if you remember. I show you, I will clarify again. We can see that we have two equations. One is in a differential equation. X dot vector equals A matrix, which multiply X vector plus B vector or matrix. In our case, will be a vector because we have just one input. Multiply U of t. In our case, U of t is an input, it's input force. The second equation is an easy equation, which characterize the output, which I didn't specify. I will specify exactly now in this context here. But we can see that the right part of this equation is exactly in the sense reflects this equation here, because we can see that this depends of x, the vector x depends of input, the unique input which I have, f of t, or generally we say u. Huh? But we have somehow two matrices, or matrices and vector, or two vector. We will see what I am asking about why. This you can find as an indication somehow, no? We can see state space structure. We have seen during the semester, but reflect what I intend with state space structure in the context of linear system. I don't write everything, but you remember, no? We are speaking at this moment with linear system. About the nonlinear system, I will ask really a few things about the equilibrium points. Now, what is y in which the output of the system, because the model, to remember what we did during the semester, is characterized by states, very important, which we reflected the energy, input, what are inputs, force, motoric force, and output, what outputs, we remember this. This means I can ask during the examination, in the text, these elements, clear, no? Okay, this means in which the output y of t could be capitalized, not capitalized. In this case, it's not capitalized because I consider just one output, z of t. Please pay attention. In the exam, I can ask z dot. I can ask z dot dot. We have seen during the semester all this possibility. Huh? Clear what I think. I don't have time to do all these cases. Please look at the lectures. But I will announce that it could be that I ask z dot. Again, I cannot say what I can ask on Friday, but I say that it is possible to calculate, to have an output which is not z, that could be z dot, could be z dot dot. Look at the lecture in which I considered many different also output. It's fair. No, I say, please pay attention. I can variate because I cannot say what I will ask. Also, it could be that the system is not exactly this, but something like. I cannot really say what we have on Friday. But the set is clear. Could be Z, could be Z dot, but doesn't change much, believe me. I will sketch the solution also. The question, it seems to be completed. No? I understand that it's not so very nice. Let me answer. Question about the question? No? Clear. Now, what is X? You remember, three things are important in building the model. States, the most, why not? The most important. Input, or the inputs, we have one input, f of t. U of t is f of t in our language. And the output, z of t, position. Basically, the idea later that I want to observe, I want to analyze, I want to control the position. But it could be that in the exam, I want to control the velocity. Do you remember the car? I did the car, no? Okay, I can control also the position. Why not? Through GPS, we are not here to learn such things, but you can understand that we can apply some algorithms in control and in the different application. And during the semester, I controlled the velocity, I think. But it doesn't matter. We will see that it's really easy to switch because the structure of our tool is so flexible that really we can apply it with small variations, different problem. No? Because to control the velocity is totally different conceptually to control the position. One is the cruise control the velocity, another one is auto parking. But in the structure of the dynamics, in the structure of our representation, really changes a few things. Okay, this means what is the X? Answer, no? Answer number 3. Capital I because in a vector is z of t and z dot of t. Very often, we change the notation. And very often, this is okay, no? Position and velocity. Very often in the literature, as in the lecture, we call set of t equal z1 of t. It's just in a position. If you don't like, you can remain with this. But in accordance with what we did in the lecture during the semester, as in accordance which we can find mostly in the book, we changed the name. Why that? Because it's more practical. Basically, we call set of t z1, set derivative z2. Just in a position in order to reflect what we did during the semester, which is exactly very often what we can find in the book. This means, now the reason I clarify, because typically we don't like to put in the x variable and its derivative. We say position is z1, velocity is z2. Clear, no? With this position here, we say that we call the position z1 with this nomenclature and the velocity z2. The meaning is just this one because we don't want aesthetically to have this, but it's the same. If you don't like this position, you can maintain this. But I would like to suggest this because it's not typical. Clear, no? This means state is already, you can also comment with state if you like, no? State vector. So it's clear what it is. Then input, it's not a problem because u of t is f of t. And the output, the position. This means y of t, z of t, in order to repeat, z1, excuse me. In accordance with this position, y is z1. Huh? Now, build the model. Z x dot, now it's easy, because it's z1 dot, z2 dot. It is enough to do the derivative of this vector here, if you want to use this notation here. If you don't want to use this notation here, we have z dot here and z dot dot. But you can see also a little bit heavy, to bring z dot dot. Anyway, But if you don't like this position, you can work with this. But here we have z dot dot instead of z2 dot. The notation is reflected as the homogeneity of the notation, if you like. Because do you remember, the derivative which reflect the changes equals the derivative of the states, clear, equal the state, something as a function of state and of the plus the input. Do you remember, free and force? No? This reflect this area here. Therefore, the notation, I don't want to say is more appropriate, but reflect changes of position, changes of velocity on the left, which is the function of position and velocity and input. Okay. Now, how we can build in this state space structure our model? Look, we started from this equation. You remember this? Not easy. This was our starting. This was our model, build a mathematical model, physical mathematical model, but we call mathematical model. This was our starting point. Now, how I can build the state space structure starting from here? It's not so difficult because, look, this expression here says that z1 dot, this means the derivative of the position, is the velocity. The derivative of the position is the velocity. It's written here. Z dot equal z2 means z1 dot equal z2. I don't know if it's clear, because z1 is equal to z. Now, the key point is everything must be written in terms of z1 and z2. Forget z. And in order to write everything in terms of z1 and z2, we have to consider this position. It's clear, this, yeah? It's clear. But now, if this is clear, from this equation here, we can say that z2 dot equal what? 1 divided m, because I can directly divide everything by m, which multiplied f of t minus kv, which multiplied z2 of t. I clarify again. If this is clear, because the derivative of the position is equal to the velocity, we should not to clarify this equation. The derivative of the position is equal to the velocity in accordance with our new notation, z1, z2. The derivative of the velocity is the acceleration. This means it's z dot dot. I can divide it everything by m. This is easy to see that m here corresponds to 1 divided m on the other part. And here what we have? F does not change because it's an external signal, minus kv multiplied the velocity. Z dot was the velocity. I starting exactly with this definition. Z dot is the velocity. From here now, if this is clear, it's extremely easy to build the state space structure of the model. Just considering what I wrote here. Particularly this expression. Why that? Because I can consider now to, let me say, vectorialize this expression. How? I consider the vector of the left part. When I say vectorialize, I am saying exactly that I consider these two elements in one vector. Equal what? The matrix A, in accordance with the scheme which I put in the other side, which multiply the vector z1 and z2 consist of z1 and z2. Here we have again x capitalized dot, exactly this, no? And here we have x. Plus a vector multiply f of t. How are you? our U. What about the matrix A? 0, 1. Why that? Because row multiply column. I will reconstruct this form here, this information. Row multiply column is reflect is Z1 dot equal Z2. This means here we have a 0 because we don't have here any contribution in terms of F. Clear, no? We don't have any contribution. What about the second line? 0 minus KV divided M. We can see that we have to reconstruct. I have to reconstruct this information. 1 divided M multiply KV multiplied Z2. Yeah, I have something because F appears in the second equation. This means 1 divided M. Almost ready? Yeah, because Y of t must be reflected or must be written in a function again with Z1 and Z2, because the structure of these two equations is basically the same in the sense should be in a function of the statics and the input. This was matrix C. This was matrix D in accordance with the scheme which you can find in the preview page. But this is easy, no? 1, 0, no? Row multiply column, Y of t equals Z1 is in accordance with the definition. Definition. What I want to observe, what I want to control, the position. But please, at home, if you want to control the velocity, here is 0, this is 1. Please pay attention. If I ask about the velocity, here is 0, this is 1. A little bit more complicated, here is 0. No? If I ask the acceleration, but you can find the example in my study. If I ask for the acceleration, d is not 0. But nevertheless, it's easy, the acceleration, because it's this expression. The acceleration is here. This means instead of 0, I have 1 divided m. Please pay attention. Instead of 0, I have 1 divided m. And here, we have 0 minus kv divided m. I don't know if it's clear what I intend. In case I ask the acceleration, in case I ask the velocity is easy, no? 0, 1, here does not change. If I'm asking about the acceleration, we have, this is not 0. What is? This is the acceleration. Set y dot. This means here, instead of 0, I have 1 divided m, because f is multiplied by 1 divided m. But what I have here, I have to consider something which is multiplied by Z2, which is this something, is minus kv divided m. This means here we have a 0, because I don't have here any x1, Z1, excuse me. And here I have minus kv divided m is equal to the acceleration. Okay, we answered the question number 3, also with some variations. I didn't write. Should I write the variation? No. Read what I want to have. You know, set try 0, 1 for C and D remain at 0, because I don't have the contribution in terms of if I consider the velocity of F. If I consider the acceleration, but that this you remember also from physics, I clarify many times, the acceleration is connected with the force. But if you don't remember this, look at mathematics. Why I try to ask at the beginning, build the model. Because here we have the acceleration. The acceleration is clear what it is. And then to transfer this information in terms of matrix in accordance with our structure is extremely easy, because the acceleration isn't a function of the velocity in terms of it's the velocity multiplied minus kv divided m. We can see from here. This means this matrix here consists 0 and minus kv divided m. Because row multiply column, I will get this information in accordance with the model. What about D? This is 1 divided m, because it's the element which will multiply F. The exercise consists just reading what you already wrote. Of course, physically, you can consider that the acceleration is connected directly with the force in the sense. No, we know from high school, no, force, acceleration, they are m multiply acceleration equal f. No, this means they are, let me say, at the same level. No? Question, yeah, it's easy. Think about the variations too, because I cannot say what I will put on Friday. I cannot say, I mean, we have, if the system is a mechanical one, we have just three possibilities because we didn't consider multi-output, no? At least not in the control. What I can ask, for instance, to represent an output, two outputs, but for the control, I just presented just one variable to be controlled, not two variables, because this is, I need more time. I don't know if it's clear what I intend. I can ask here, please control acceleration and position. Should I do it? Not control, to represent, excuse me. But for the control, just one I will choose. Because we didn't do multi-output control, just one output in control. Because this is really heavy, I need a course in control. Here is math 1, math 2, system theory, and control a little bit. I show you what I intend. If I ask for the representation, position and acceleration, for instance, no? Let me show it's clear, more clear. If I ask, please represent y of t equal zeta 1, z2 derivative. This means position and acceleration. Clear? Again, just a possible question in the representation, but not in the control, because this is it's complicated. You know why? Why? Because we have an underactuated system. We have one input, and we have to control two things. You understand that this is possible, but we didn't do. I have to introduce many things which I didn't have time to do. In German, we say wir müssen mit einer Patrone zwei Tauben. Ne? Das ist möglich. Aber die Taube sollte wir muss finden einen Winkel, dass die beide sind derselbe Line. Entschuldigung, genau, wenn ich trivialisiere, aber auch in der Kontrolle so. Wir müssen etwas, aber nicht clarify, what is the meaning control von das mögliche, der possible direction, ne? Mögliche Richtung. Mit einer Taube, mit zwei Tauben, wenn wir haben zwei Tauben, mit einem Patron ist möglich. Aber er muss in eine Position, das sind in eine Line. Entschuldigung, eine Trivialisierung, aber das reflekt, dass wir den Control, wir machen eine different position reference mit Matrizen, complicated. Of course, if I have two inputs, two patrone, das ist schon, we can see many things in control, with analogy, but of course, in any case, with one input and to control, to have two goals, it's a little bit more difficult. Okay, this exercise. We can call here, if you don't like here, we can call here Z3. I don't know if you like. This is why, no? Why capitalize? Why capitalize? Because we have in a vector. This could be Z3 if you don't like. If you don't like to have the dot. But I already told you the solution. Because I did separately position and velocity, and now I have to put all together. If I want to obtain or to have to achieve two goals with one input, this means all together. we didn't do how we can manage this kind of control if the output is represented in this form. This means we did just separately, which is totally different. But I can ask about the representation, but I will never ask about the control because we didn't do multi-output control. Okay, it's clear, no? Now this representation. The second line came, look at the model. Set to dot. It's clear what is. The acceleration is not ambiguous. It's a deterministic equation. Okay. Question number 4, no? Please represent the system in form, in terms, in form is better, of block diagram. We have seen also this in actuator, no? Do you remember in actuator? Did you do? Yeah, this means 1 minute to do. Now, this could be done in different form. You can consider the matrices, or you can consider directly the mathematical representation. I mean, everything which I'm doing now is starting from originally from this graphical model to represent with another language, the language of the mathematics. No? This information here and this form here, and this information here in the matrix form. It's just in a different representation, different language. Now, another language is the block diagram. This means, let me start, I don't know what is for you, probably this, which is the last one. But if you don't like this, you can also start from this. It could be that this is more familiar because we have seen this in actuator, I think. No? It doesn't matter which kind of representation you consider to start the translation. Block is another language. This means from a language to another language, well, we need a translation. Do you like this, probably? You can start from this, or you can start from the matrix, as you want. But let me start from this. Probably recall, this language here recalls the actuator. This means starting from for instance, not necessary. Z dot m multiplied z dot equals f of t minus kv multiplied z dot, which can be written something like that. We can build everything. Z of t, which can be seen as the integral of z derivative, which can be seen as the integral with z dot. Of course, here I try to introduce again with respect to what I told you during the semester, the initial conditions, no? Because now I need also for free and forced answer. No? I will explain later, but you remember, no, a little bit. I will finish and then I try to explain. Huh? This is the solution of the answer, in which we can see the introduction of two initial conditions. Because in the block diagram, if you remember in Simulink, I think once I simulated, but in any case, in math, no? To solve an integral, at least practically, not only in abstract form, we need the initial conditions, or in general, also in a differential equation, if I ask now the next question is free and forced answer, we need initial conditions. At this moment, I don't know, I didn't specify any initial condition. But as with this symbol here, I assume that there is a value. Could be zero, but it is. I don't know. Something like here, something like here. This means I have initial condition. At this moment, I didn't declare which one. But in order to work with this language here, of course, to be precise, I have to include also the initial conditions also in the differential equations. Also here. Also in the matrix form. But the question was build the model. You understand what it is? Build the model. Here, when I speak about the block diagrams, the block diagram recalls, at least if you think about my lecture, recalls in a practical application, Simulink, in any kind of tools which use the block diagrams in practical application. Therefore, I try to introduce now the initial conditions in order to reflect what I told you during the semester, in order to recall Simulink. But if you forget the initial condition, this is not an error. No, I can understand that. It's not possible to forget, because if you work with MATLAB, if you forget, MATLAB puts zero. No? Okay, I think, yeah, question me.
Because down we have the minus KE, and we also have the minus at the side, so it's a double minus.
Thank you. Excuse me if I made mistakes. Thank you. Yeah. Very important that at the end of the semester that the students correct the professor, because this is the proof that you are not here in vain. In vain is German is vergeblich. Ne? Yeah, it's plus. Or you can put plus here and minus here. Very good. Other errors? Did you see other errors? Okay. Question. Now, our original idea about free and forced. No? But we can see that in the exam, we have a logical, I don't know if it's logical, but in the path, we reflect exactly what we do during our work. I mean, I worked, an interesting thing which I already told you. I come from industry. My scientific career, I built an industry, not in the academic. I'm here professor. I started here many years ago. It's a shame. But I work in industry. I come from industry. Yeah, okay, I did the postdoc, the doctor, okay. But then for a long period, I work in industry. And this is the way, of course, the project is more complex, but conceptually is this. Non-linear, everything. But starting from a system, a real system, we sketch graphically what is, and then we use different language, and then we implement in MATLAB Simulink, and then so we try to develop the prototype and so on. Question about free and forced, no? Because it was a very important chapter which can be used with different structure also in nonlinear system. Do you remember yesterday? In simulating, we use the simulation and try to see the answer with and without input. Remember this in the COVID. Okay. 4. Question number 5 or like that. Where is? Yeah. Question number 5 is, please, again, calculate, I don't know, represent the free answer of the system, considering theta 1 let me do something interesting for you. Equal 0 and theta 2 of 0 equal 1. 1 is 1 meter per second, but forget the, if you want, I can write. This is the velocity, it's clear, this 1 meter per second. This is the velocity, remember, theta 2. Even though I didn't write, it's clear. I mean, could be also kilometer per hour, but in the velocity, understand? But for us, it's 1. Should I write meter per second or kilometer per, it's in the velocity. Let me go as abstract, because the example. And mass equal 1. Of course, mass is 1 kilo. kV 25. Newton per second divided meter. Let me write everything. So it's clear what I intend. Answer 4. Are you tired? I would like to do 3 and 4, that we take a little bit rest, okay? So I have the possibility to take my stuff, but it's enough. It's enough. And yeah, question. Should it?
Four, but square complies not five. We already met 4.
Question 4. You intend the yes response 4, no?
No. I mean, it's not 4, it's 5.
It's 5.
It's the fifth question.
Let me see, because I forgot the numeration probably. Yeah, you're right. I forgot this 5. You're right, excuse me. Correct. Okay. Yeah. This means you have to consider this problem here now. Yeah, we can consider Z1 dot free, remember, in our notation of T equal 1 divided M, which multiply. I in mind exactly what is. Yeah? This is the equation in terms of free, but here should be 0. I can directly write 0 if you want, no? But just to emphasize again this concept that sometimes the students, yeah, I don't want to say mistakes, but yeah. including the two initial conditions. This is 0. This means at the end we have something like that. Zero. Free means autonomous, no? Without input. And also the initial condition, which I didn't rewrite here. Then this kind of problem can be solved directly from here, or more easily using, you remember, I held a lecture with the calculation directly of lambda, determinant of lambda I minus a equals 0. Do you remember this long lecture I showed you? If you don't write in this form, so we repeat it also, but you write everything in this form here. I'm a bit with z with x. Free is quite a little bit more easy, I would like to say. Remember this form. And the two initial conditions. Now, if I calculate the eigenvalue, in which this is the matrix A, no, let me write it. Determinant of lambda I, do you remember this? Minus A. I told a lot about this. This matrix A, I don't remember if I indicated probably yes. No, I didn't indicate, but is this. This is the vector B in accordance with our notation. I can, everywhere I can, I did indicate, but I told you. What is the mistake? Tell me if I told you, but I forgot to put A and B, no? A, B, C, D, no? We have seen many times, just to be clear that I repeated again the matrix. This means also here at the end, where is, yeah, you have a matrix A. Here I can write B, but multiply 0, I didn't put. Because I emphasize again the concept f of t is equal to 0 in the free. This means become this. But in my opinion, it's very quickly to consider this. You remember the lecture related to the eigenvalue, with which we can build directly the free answer. Because the free answer, basically the exercise of the free answer consists first of all to calculate lambda 1 and lambda 2 in this case. And then the parameters C1 and C2, which multiply these two eigenfunctions. It's extremely easy to do. If you remember, but if you don't remember, I will put in the data sheet this. Do you remember the lecture 2 or 3 weeks ago? This. Just to apply this. I told a lot, I think one full lecture about this. -1. If you see some error, because but I don't see one. If I don't see this, doesn't mean that it's free of error. No. What is this determinant? Do you remember? This 2 times 2 as in definition, this multiply this minus this multiply this. I don't have to do because it's 0. No? We have lambda 1 equals 0 and lambda 2 equals minus kV divided m. 5 seconds. Taken back. And then we have now our structural free answer already calculated. Otherwise, I have to think, as at the beginning of the semester, more physically, assuming that we have a solution which can be expressed in form for an exponential function. It doesn't matter which form you did, but this lecture here about this equation, I did 2 weeks or 3 weeks ago, but really this is speed up the method, and I would like to suggest for next week to use it. But probably if you want to use your knowledge in math, eigenfunction experiment, you can do. At the beginning, I recalled just, I don't know if you remember, the structure of the math 1 or the math 2, which assuming that the solution is an exponential function, and calculation, but it's too long. Here, too long, you can do. Here we learn something more, I don't know, but in terms of why the idea to put everything in form of states. The idea is to use the computer. The idea is to realize, we will see in the second block, to realize the control. Now, what is the structural form of the free answer? Is C1, you remember, exponential function up to lambda 1 plus C2 exponential function, excuse me, t, up to lambda 2 multiply t. Don't forget t. Remember this. You can achieve this also with the method which I presented at the beginning of the semester, because at the beginning we didn't do the matrix, we didn't do state space. The idea was to recall your knowledge in math, but connected to the free and forced answer, which is in dynamical system is typically the way to approach, because it's more physical, free without external input, but with internal input, which is the energy, the initial energy. I don't know if you see in German, we say the Rotfahrt a little bit. Okay, but this is exactly what we do in my lab, and not only what we really did when I work. I am still working with industry in the project. This is exactly what we did. Of course, very often in more complex system in terms of nonlinear and so on. Now, how to calculate C1 and C2? Easy. We have 2 initial conditions. Because now the problem is this. It's easy, an easy problem. Why that? Because the differential equation you already solved very quickly using the determinant of lambda I minus A equals 0. Directly. Right away. Excuse me. At time 0. This is 0 if I don't know if I remember well. I think so. No? And the derivative, it's Z2, which is the derivative of Z1 at time 0 was 1. No? This is now the problem is 1. Z2, I consider the derivative because I already have this form. how we can do is enough to calculate the derivative of this, no? In order to use also this information. This is directly possible to use. The derivative here is lambda 1 multiply C1. Well, we know lambda 1, but let me go symbolically. The derivative, this is this one. Let me now put the values. Or at least, yeah, why not? Here we have C1 because lambda 1 was 0, no? Lambda 1 was 0. And this lambda 2 was minus k divided m. Minus kv divided m. Correct if I made some mistakes. And set 1 derivative, which is set 2, or the free in any case, no? Basically the velocity, no? In the free context, let me say so. This is 0 because lambda 1 is 0. This is minus kv divided m exponential function of minus kv divided m multiplied t. Look if I made mistakes. Now I have to use the initial condition. This means at time 0, this must be 0. Let me consider this. Set 1 free at time 0. Means 0, because this is 0. No? Let me write so. From here, no? Equals C1 plus C2 equals 0. Did you agree? No? Because this is 1. Math. This implies, here I forgot C2. No? Please correct if I made mistakes. No? Is minus C2. No? Yeah. Please pay attention. I forgot C2 here. No? Must be. Lambda 2 was minus kv divided m, multiply C2 that remains. From this, we know that C2 is equal minus C1. We know using this condition. And let me now consider the second condition. Set 1 dot free, which is equal set 2 no? At time 0, equal 1 in this case, right? It's written here. No? We did a lot of time also in math, I think. No, this is not. Now here we have seen, and let me say in a different form, but no problems. This means 1, I have to use this. C2 kV divided m exponential up to minus kV divided m at time 0, which is 1. Excuse me, 1. Basically, at the end, we have that C2 is equal m divided minus m. Let me write better. Divided k. Look if I made mistakes. Minus m divided k. kv from here. Because this is 1. Right? We have everything. Because C1 is minus C2 from here. C1 is minus C2. This implies that C1 is, in this case, m divided kv. Conclusion, Z1 free of t equals m divided kv plus, in this case, minus, I would like to write, because C2 is minus C1, m divided kv, which multiplied exponential function of minus kv divided m multiplied t. The output is, if the output is Z1, if the output is Z2, you have to do the derivative. In free context, no, I don't repeat, we are still in free context. If I ask for Z2 in the original question, everything oriented on velocity, the derivatives. What about the acceleration? Second derivative, dot, dot. But the derivative, I don't need to repeat it. The derivative is easy. No? We have exponential function, no problem. I think once you did math 1, math 2, at the end of my course, which I repeated many things, that no problem to do the derivative. I don't do. But it could be that I ask the velocity instead of the derivative. I don't have time. Try to do at home eventually in electrical systems. But once we have the model, it does not matter if the system is an electrical system, mechanical one. We have seen just mechanical and electrical, not different. But because I didn't have time to show you hydraulic system, pneumatic system, but once you have the model, it's the same, everything. But of course, in the course, I told you just mechanical and electrical, look at the material. But once you have the model through the Kirchhoff law, we have a matrices. It doesn't matter what. We have seen just mechanical and electrical. Now, today, I consider just the mechanical. I don't have time to do both. But once you build the model through look at my style, the rest is exactly the same. The control does not care about which kind of model. We have seen very quickly the COVID. The control does not care if you're controlling the COVID, let me say, situation, the bank situation, or about the bank, I didn't tell you, but if you are interested in my field, I have for bachelor students 2 possible complementary classes. It is possible to choose 2 complementary by me. Kalman filter, the upcoming semester, and later control, modeling of biological, economical, and everything. Fourth answer. To calculate the fourth answer, I have to give an f of t. Otherwise, if it's not clear f of t, you cannot do the calculation. I mean, too abstract. This means question number 6 now. No? Calculate, represent, it doesn't matter. The fourth answer, or the response answer, let me say, considering f of t equal, what do we want to do? Look, please, in my study. I did constant force, F equal 1. I did ramp, F of t equal t or the 2t. Please do at all. Today we do that the robot do something like that. Cosinus of t. This means try to realize an oscillation. Please at home, because I cannot say what we are doing the exam. Try to do f of t equals constant. 1, 2, 3, doesn't matter. A constant, very important. F of t equals t, 2t, 3t, and a ramp. More than a ramp is not a problem, but too many calculations. But does not matter conceptually. But I will never put t up to 3. Possible, but it's just a lot of calculation. Look, nevertheless, in my study. And today we will do something particular, cosinus of t. This means that the robot try to realize oscillation. Why that? At this moment, I will don't tell you, because this example which I put, I don't see any reasons. But the robot can consider to realize an oscillation for different applications. Okay, cosine of t is okay. Do at home polynomial order 1, the constant. So we have this possibility which I told you in the exam. I will never put in the exam t up to 2, because no difference conceptually with respect to t, but a lot of calculations. If you look for your curiosity, we did once, I think, something like that. Please pay attention, try to do at home. Oh, I do 2t twice the frequency. Should be nice, 2. This is better, more general, no? Cosine of those 2t. What is 2 is the omega, no? Math is the pulsation. Omega equals 2 pi phi, f, excuse me. It's the frequency, but normalize with respect to pi. No? This technical aspect, forget in the exam. For us, I have to just to verify that you understood the concept, but just to see what is this 2 is. Let me say how fast should move. If I put 1 with respect to 2, 1 is the half of the frequency, because omega is 2 pi f the frequency. But this could be useful in the project when we have to really work with the values. Tired? I have time to do, and then we will. The second part we do the control. And the last example is equilibrium points, which is the last topic possible, because we did 2 weeks ago. No, this is, but it's extremely easy. This is no problem. It's okay now if I do, or do we want to do the rest now? Take the rest, or we do that. Huh? This is the page number 5, something like that. The page number 6. Fourth answer, no? Answer response 6. Yeah. If you remember the structure of the fourth answer, let me write for you so you can find. Is the general free answer plus the particular solution of the function which reflect the input. Roughly speaking, why that? Because if I put an input, the evolution of the answer is related to the energy which is growing up. This means the initial condition which changes, and the steady state, which basically reflect when the transient is already finished. This means I can assume, and we have seen during the semester, that this part here I demonstrate mathematically. Does this part here belong to the fourth? I demonstrate this. Why it belong to the fourth? Because nevertheless, isn't a solution of the general problem we consider now this problem here. 1 second. Was the original problem in fourths. is, do you remember this? Just to interpret a little bit. Minus, excuse me. Now, the f of t is this, no? In our specific form. Characterized by, this is the original problem. 0, no? Here, please don't forget this. But this problem here, we demonstrate during the semester that consists of this solution independently of K1 and K2. Because solves when f of t is equal to 0. Plus something particular, which consider the presence of ft in steady state. Basically, we can split the solution. This is a part of this problem here. Which takes into account the transient, and the part which takes into account the steady state. Because this kind of problem consists of an transient and a steady state. We can demonstrate mathematically that this here solve nevertheless the problem, or the part of the problem which is dedicated to the steady state. The transient. Let me calculate now this function here, because this is everything calculated, and then at the end I calculate K1 and K2, excuse me, considering these initial conditions, because K1 and K2 depends on the initial condition. Okay, let me calculate this here. How we can do? Easy. Because if this is the solution, I have just to calculate. If this is the solution, this means if I plug in this, we will cancel between this and this. Do you remember the idea? If you do the derivative, first derivative of this, and I plug in here. If you do the second derivative of this, and I plug in here, I will cancel everything. What will remain is just the contribution of this. Meaning, what I have to do is this. We did during the semester. The derivative of cosine minus sine, right? Yeah, I come to you.
What again is it's not like a line about the C1 for that? What's the difference between the...
What is written? Excuse me, I didn't hear.
What is the difference
between
C1 with the line covered now for the particular part?
Here.
Yes. Why does
I can assume that the solution of this original problem, thank you for this question, consists of two parts. One which reflects the free answer. Why that? Because we demonstrated mathematically that if I do the derivative of this first derivative, if I do that, then I come to your answer, to the question. If I do the second derivative and I plug in here, the contribution of the exponential function, we will cancel. And we will remain the contribution of this. But the contribution of this must be, let me say, must reflect a contribution which reflects the steady state answer. This means what remains after the transient. The difference between this and this is the global solution in terms of force. This is just the steady state analysis or solution which remains after the transient. During the semester, I showed exactly that if I plug in this first derivative here, second derivative here, I will find conditions, just a condition about this, because this we will cancel between this contribution and this contribution. This means this here with respect to this is the global solution minus the transient. This means you understand that this is the transient because it depends of the exponential function, which is a constant, and this is the really this is not exactly the transient, but it's something which is compensated mathematically if I plug in here. Now I don't have time to show you, but the difference, this is the particular, if you remember your knowledge in math, it's a particular solution of this Cauchy problem. In dynamical systems, is a component of the steady state, let me say, analysis. And we come back when I find the solution. First derivative of this particular solution which I am trying to find. The derivative of the sine is cosine, right? I have to multiply by the argument. Now, if I plug in this here, without caring about this, because I can demonstrate that this will compensate it between this contribution and this contribution. This means if I do the derivative of this part here, of this solution here, the second derivative of this part, of this right part, and I put here, if I do the first derivative of the right part and I put here, we will remain, I show you what. We will remain with this. Because this part here, we will cancel. Because the second derivative of this part here equals minus kv divided m, the first derivative of this. I can show you, we can find in my study. I don't know if I copy correct. It will remain just this condition. This is this one. Let me see if I may. I don't think so. It seems to be correct. Now, how we can solve this? Yeah, we can see from this condition that we have excuse me, I forgot to put here a parameter. No? A and A, no? Otherwise I cannot find the solution. I will repeat a little bit why this parameter. The idea is to think that Z1 tilde forced, I forgot it too fast. Yeah, I have to do some correction, excuse me. I am thinking that the particular form is A multiply cosine of 2t plus B, excuse me, I made mistakes. I mean too fast. Meaning, I am assuming that in a general solution, then we calculate A and B. In a general solution, could consist in a linear combination of sinus cosine of 2t. Why that? Because the forcing was in a trigonometric function. It doesn't matter of sine and cosine. Through the system, the output, which in our case is theta 1, this particular theta 1, let me say that remains steady state, is in a linear combination of two trigonometric functions of the same form. Of course, it's an assumption. But in the linear system, I don't know if you remember my lecture, the system maintains the structure of the solution. Excuse me if I forgot. Now I redo the derivative. This is not so difficult to correct. This here is the derivative of this. Then I have to consider also this here. Excuse me, I a little bit tired. No? Then the derivative of this is correct. And the derivative of this is minus 4b sinus of 2t. No? The derivative of the cosinus minus sine. Now, let me rewrite this because I have to put some element more. Could be for there. Again, I am assuming that the output of the system in terms of position, in our case, reflects, let me use this interesting word, reflect the forcing input. Now, reflect means, in general, a linear combination of trigonometric function with the same frequency. It's an assumption, of course, but in linear system, we can also demonstrate that this is a valid assumption. Now, did you agree that the first derivative of this is this, the second derivative is this one? Let me see if I made mistakes. No, it's okay. This means now, please rewrite this element on the right part. Look if I made mistakes. I don't think so. Here is the input. Excuse. I'm so stupid. This is better to do directly. No? I needed to stop a little bit, but let me write. I don't know if it's visible. Plus, let me write so, 2b cosine of 2t. I try to read. This part here is this here because I put it here. 1 divided m is here. The forcing element is here as this. And here we have minus kv divided m. No, mistakes. No, it's correct. It's correct. Minus km. kv divided m. The derivative, first derivative of this element here is this one. Now, the idea is to calculate a and b. Exist, believe me, if I did make mistake. I don't see any mistakes. It's okay, no? Check, please. I have mistakes here, minus. I have mistakes here, minus. As I told you, we need the rest.
Also,
Other mistakes?
the very first 4.8%. No. Very first.
Let me see. The derivative of sine is cosine.
Yeah.
This means maintain the minus, no? I don't see mistake from here to here. From here to here, I don't see mistake.
For the first derivative, it's minus 2a.
This derivative is okay.
Yes.
Now, from here to here, the derivative of sine is cosine. Of course, I have to multiply by the factor 2 because it's the function of a function. Huh?
Yeah.
The derivative of cosine is minus sine.
Although we already have minus sign in the first, we have minus 2a minus 2. And then it's the derivative.
We have minus 1 times sine. And the times 2 minus 1.
What is the error? From here to here?
Yeah.
Okay, the derivative of sine is cosine, and I have to multiply by this. Did you agree? This means this minus remains. Now, the derivative of cosine is minus sign. This means I have to change this sign. And then I have to copy, basically. Copy where? Here.
minus sign.
Uh,
It was cosine. It turns into minus sign.
This from here to here is correct, or not? The derivative of cosine is minus. The derivative of cosine is minus sine. Again, we will repeat together from here to here. The derivative of cosine is minus sine, right? Look in Google. If it could do like many mistakes, but I think is minus sine. This means in accordance it is. The derivative of sine is cosine. This means this sign does not change. The same rule I have to apply later. Yeah, let me do now the solution here quickly. Look, we have cosine here, we have a cosine here, and we have a cosine here. The condition is minus 4a equals 1 divided m minus kv divided m square multiply 2b together with 0, because here we don't have sine, excuse me, 4b, we have sinus, no? Right? Minus 4 times b equal what? Just this, right? kv divided m squared, because minus multiply minus is plus, which multiply 2a. Look at this condition to guarantee the identity. I have to guarantee that the left is equal to right. This means in terms of sign, we have minus 4b equal what? Here cosine I don't have to consider. I have just this part here. Minus multiply minus is plus. kv divided m squared, because this here, 2a. And then I have to calculate a and b. This means from the second, I can write that, for instance, b is equal minus 1 divided 2, which multiply kv divided m squared a, right? Minus 1 divided 2. Did you agree with b, no? Now, if I plug in here and suck, I go here, let me sketch in this form. We have a minus 4a equals 1 divided m minus, which becomes plus, because this minus here, kv squared divided m up to 4, right? If I plug in this here, assuming that I didn't make mistakes. Minus and minus become plus, kv and kv squared, but here we have also m squared and m squared. Multiply a, yeah? Right. A little bit boring, but I can write here. Mistakes? No, I don't think so. Minus 4 minus kv squared divided m up to 4 multiply a equal 1 divided m. And I can calculate a. I finished the place. You have another slide, right? Yeah. Look. If I made mistakes in the calculation, that is easy to do some mistakes, but I don't see it. Oh, thank you, really. Too many. Now we take a rest. I go to fix some. This means page number 7. A is equal 1 divided M, let me say with a minus, then we have here M up to 4 divided 4 M up to 4 minus KV squared, right? From here to here. This means B, in accordance to what is written here, is 1 divided 2 KV divided M squared, multiply this. Of course, if you put in the exam the value of M, I had, but I didn't put it. The calculation probably simplified because we have values. No? We have values for KV, we have values for M. Do you remember M is 1? This means you don't have to write, please pay attention to the exam. You don't have to write so many things. M is 1, KV is 25, many things can be simplified. Let me see if I made some mistakes. Y plus because it's minus minus. Let me write multiply cosine of 2t plus 1 divided 2 KV divided M squared with multiply M, we can see M up to 3, but let me write so. Probably in the exam, if I have something like this, it could be useful to write the values. No? Try to do at home to calculate K1 and K2, but it's easy, but very boring, using the initial condition. Set 1/4 at time 0 is 0. Set 1/4 derivative at time 0 is 0. We can find K1 and K2. It's quite boring. Let me write. Try to calculate K1 and K2 using what? Say 1/4 at time 0 equals 0, very important, and set 1 derivative 4th at time 0 again 0. Of course, it's boring, extremely boring. It could be a little bit, let me say, simplified if you put the values, of course. But I would like to put the value directly at the beginning. I didn't do because I forgot that I gave you the value. We have a value. I don't know if I have some mistakes, but I don't think so. Yeah, of course, you have M up to 3. Please try to do it. It's extremely boring. A little bit easy if you put really the value. Because M is equal 1, and so on. Look, if I have made mistakes, it is better to take a rest a little bit. Okay, let me stop recording. I have to recover stuff for the second part, in which we will see symbolically, without calculations, the dynamics of the controller, and then very quickly and equilibrium points. Yeah, we have here an error. Here is everything is okay. The error is here. No? There should be a plus instead of minus. The rest we checked. It seems to be a plus plus instead of minus. Again, try to calculate K1 and K2, but considering the exact the initial condition 0, 0 for position force and velocity force, as in accordance with the definition. Please pay attention in the exam. X1 of t, the final, is x1 free, once we calculate it, plus x1 forced. I know this is boring. But basically, it's the final solution in accordance with the superposition principle. In the last 2 weeks, I told you that the superposition principle does not work in nonlinear system. Okay. Now, control. Control, it's, I hope, not so boring. As I told you, will appear in state space integral control because it's the most general, it's the most used. It's what we did more in detail. It is more complex with respect to the other one. This means if you show me that you are able to do that, of course, you understood. I think you understood also easier control. Let me formulate the problem. This is the question number 7. Yeah. Or 8, I don't remember. 7, I think. Question number 7. Again, considering the same system, of course. Of course, in the exam, you can find something read a little bit better, considering the same system a little bit strange, but let me go ahead. Comma. Then, please control the output Z1 of t position. Of course, we will discuss together what change if I consider the velocity. No, we will see. With consider the same system, then please control the output Z1 with the following control structure. The control structure is U of t, which in our case is F of t. You remember in the exam, it could be that we can find U, but U is F, no? The input force. Equal what? Minus Ki in accordance with the definition, we multiply our vector state vector in the sense. This means, but Ki probably we use, I don't remember K, the notation, I think just K, and then Ki, let me say K. No? I don't remember. It should be nice if I am consistent with the lecture, but I don't remember. No? Which multiply X. Let me write so. Then we will see what X is. No? Yeah, I think K. Minus, again, Ki, here probably we use plus. I don't remember. Do you remember? Believe me, I don't remember. Integral, but doesn't matter. It doesn't matter. Minus is plus, I clarify very well, it does not matter. Which multiply, excuse me, integral of R of t minus we have seen zeta1 of t, no? The position. In this sense, tau, excuse me, no? Because we change formally the variable, no? Which multiply d tau, no? Do you remember the integral from math, no? I think was both minus, but I don't remember it. But doesn't matter. If I put in the exam minus plus, no difference because the constant is no. I don't know if this concept is clear. No? The constants in their form are always the same. Plus, minus. Understand what I intend? It's irrelevant if I put plus, 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 minus, minus, plus. It's a constant which must be calculated in accordance with the definition which I have in the equation. Let me say everything minus. It could be that in the slide I put, let me see. Should be not totally stupid to look at the definition, so it's consistent to the whole semester. I am not sure because when we are working, when the really are working, we didn't care about sign. And now I remember what I did here. But also important to understand that the solution is always the same, independent of the, let me say, of the sign. Because C or the minus C does not have influences in the final solution. What is now? Here, let me see. Find it now. Yeah. To be prepared on fund. One of the most challenge in my age is to find what you are doing. I would like to consider everything minus. I don't find the real now. Is this solution? 1 second, probably I'll find it. Sorry. You can't believe me. I didn't find it. Does not matter. But please pay attention to the exam. I can consider a plus plus, minus plus, plus minus. We will see that no changes. In which x of t. Did you agree? It doesn't matter which sign I will consider. Do you agree? It's not a constant that we should be calculated in accordance with the definition. At the end, it's the same. Yeah. Yeah. R of t, now I will write together with the rest, is a reference signal. This means 1 centimeter, 1 meter. I mean, I try to calculate u, which is not sine, cosine, because I cosine a particular u, which allows to say that I can reach this 1 centimeter, 2 centimeter with respect to the initial position. Consider some specifications in terms of speed. How much time should I conceptually know the calculation? We need to compute. How much time I have to? I mean, I fix the time with which I will achieve my goal, and also the precision. No, with respect to 1 centimeter, 2 centimeter, I will show you now. Where exactly? In the where I will clarify everything. X of t is Z1 of t, Z2 of t, K is a column, let me say, K equals an aroma vector in the sense K11, K12, in which K11 and K12 are constant. to be calculated here, no? Ki constant to be calculated are, your question, a constant, a reference constant, given in the sense. As in a reference must be given, do you remember during the semester? We have seen just reference constant. R of t is reference constants. As a reference, is I don't write, as a reference must be given. 1 centimeter, 2 centimeter. At this moment, I put t because theoretically can be everything, also in a function. But in the exam, we will see a constant. But in general, we write constant. And a constant is also in the function of time, in the sense it's constant over time. But in general, in the lecture, you can find R of tau because we are inside the integral. But in general, yeah, again, tau t is in a formal variable inside. Tau is a formal variable inside the integral. R of t is in a reference constant given. As in a reference must be given, must be not, but in our case is given. Okay. This means, to sum up everything, we have zeta 1 of t up derivative equals zeta 2 of t. Zeta 2 derivative yeah. As a reference, in our case, is in a constant. No? It must be given. We consider just constant in the course. But of course, could be in more advanced applications, no, not only constant. Yeah, this is the model. No? F of t, our u, minus kv divided m, which multiplied z2 of t. No? Do you remember this? And now we have u of t, f of t, which is u of t. Yeah, now we have the controller, no? Together, because we try to close or to apply the controller, which is the function of states. This means you have a closed loop structure, which consists of minus, let me say, k11, k12, two constants to be calculated, which multiply. But let me write in the same form. Let me write in the same form without using matrix and so on. This is more consequent, even though it's the same. Minus k11, which multiply zeta 1 of t, minus K12, which multiply zeta 2 of t, we can see here that the controller consists of a linear combination of the states minus Ki integral, no? Which is this? R of t, of tau, but again, this is the constant given, the given constant. Now I write again this constant, minus zeta 1 of tau. Please pay attention. If I want to control zeta 2, it is enough to write here zeta 2. Please pay attention at home for tomorrow, from Friday. If the question is to control zeta 2, here we have zeta 2. Because I will compare here in a given position with the position which I have. If I want to control the velocity, here I have the velocity which I have, and here's the reference, and the reference velocity which I have to achieve. Always constant. No? Let me write here. RAT is given, and in our case, is a constant. In this case, R of t is a given position. To be reached. Is a given position to be reached. In order to understand if I change something in the exam. No? In case the goal is to control the velocity, comma, then R of t is a given constant, say, no? Constant velocity to be achieved or to be reached. And yeah, we have R of t minus, or better to say R of tau, minus Z2 of tau instead of R of tau minus Z1 of tau. Now, this must be clear, no? The error between what we want to achieve and what we have, the concept of the controller. Instead of this, at this moment we have. Question here, no, it's easy, no? We have seen many times in different situations. Okay, now we vectorialize this. For the first two equations, no problem, but please pay attention here. Why I am introducing this xi? Let me clarify. Now, the idea is, the goal is to write everything in form of state space controller. Excuse me, now the reference signal is our input. Now we discuss here together. Why this xi? What is xi? Where xi of t is equals the integral of r tau minus Z1 tau, let me say, in the tau. Why that? This is a pseudo state or augmented state, as you want, which is referred to the dynamics the new dynamics, the dynamics which is introduced thanks or because of the presence of the integral. Do you remember at the beginning of the semester I told you the states, or one state, reflect an integral. When we have an integral, we can store. You remember in gymnasium, no? The integral, with the integral, we can calculate the surface. Basically, we store the surface under the curve. If this is xi, look, now here we have that we have a minus ki, which multiply x I, right? Let me write here. This means that xi derivative equal L of t minus zeta 1 of t. I don't know if you remember this. No? And of course, equal something, if you want, equal something. But in any case, no, the derivative of this here is this minus this minus the initial condition. No? Assume it as 0 with the initial condition. Think about 1 second. Huh? Including the initial condition. Including the initial condition. Okay, this means try to fill up this matrix. Here, of course, we don't have any problem because we have 0, 1 to realize this Z2. No? We don't have any integral. Because please pay attention, you have a xi multiply ki multiply xi, no? In accordance with this. But here 0, 1, 0, no? Because to realize this. And here a little bit we have to think a little bit. Why that? Because f of t now consists of this, but it's not so difficult. First of all, we have a k11 minus k11 zeta 1, right? Zeta 1. This means here we have minus k11 divided m, no? Because this will multiply this. No? Is here. If I plug in this here, we have 1 divided m, which multiply minus k11. Everything which multiplied zeta 1. This means it's as this position. What we have in the middle? In the middle, we have, in any case, this element here divided k12, no? This means, excuse me, k12 divided m. I'm a little bit confused. Why that? Because if you plug in this expression here, we have this here. This means k11, k12 divided m with a minus, and this here. minus kV divided M. This means here in the numerator, I can consider minus kV. Let me take a little bit more place. Let me write a little bit brighter here, look a little bit wider. This means 1, 0. And what we have here, with respect to Ki, we have something. With respect to Xi, we have a minus Ki divided by Km. No? Because if I plug in this expression here, I have minus Ki M. Why that? Because this Ki multiply Xi, no? The new order, the augmented state. Ready? M square, M square. Right. Thank you for the correction. Let me rewrite everything. Thank you. Perfect. This means, let me write so here, minus K12 minus KV divided M. Now it's correct, I think, you know? Or if you like, you can write everything at the same level, but if you write everything at the same level, as you told me here, with respect to K12, we have to divide it by M. With respect to the KV, you have to divide it by M squared, as you like. Thank you for the correction. Very well. Right, no? Yeah. Is M squared, which divided KV, right? The line number 3 is easy. Why that? Because look at this expression here. Or better to say, look at this expression here. We have minus zeta1. Did you agree for this matrix? If I am asking in the exam, control the velocity, please pay attention now. We have a 0 here and minus 1 here. You can see that for the controller, with a few changes, we can control in the same way. With the same structure, more or less in this sense. What about this matrix here? The matrix B augmented in this sense. Do you agree? 0, 0, 1. Why 1? Because of this. Because of this. Of course, this one is the same one in case of you have to control the velocity, but a different meaning. In this case, it's meter, millimeter, centimeter. In this case, in the other case, it's meter per second. Physically, it's totally different, but the computer don't care about the physicality here. Yeah, again, here this was wrong. No? I mean, it's minus K12 minus KV divided M, everything divided M. Thank you for the correction. Right. Now, controller. What is the meaning to realize a controller? This is the dynamics of the control system, the general dynamics. This means the idea is once R is given, it doesn't matter what, in a constant, it's in a constant. Right here is in a constant. Is a given constant. Now, I didn't put before the specification because it was too heavy to write everything in the text. Now, I try to give you some specification. The specifications are, please, of course, in the exam you can find everything at the beginning. Now, to discuss, otherwise, heavy, no? We will find at the beginning what? Please calculate, or something like that. K11, comma. K12, comma. Ki is R is given, such that basically Here we know everything except K11, K12, and Ki. With these three parameters, we have to achieve our goal. Now, we discussed a lot during the semester the meaning between the practical goal and eigenvalues and so on. In the exam, I don't pretend this. This is more related to the project. But I will write exactly what I'm writing, something like that. Such that we have lambda 1 new, let me write so, comma, lambda 2 new, comma, lambda 3 new, given eigenvalues. Now, in the exam, everything is transformed more in mathematical example, mathematical exercise, because in the project we have to link, you remember, the eigenvalue to the rise in time, how much time I need to do. We have discussed, but I don't pretend in the exam because this is more related to the project. When we have a real system to be controlled. Yes, more conceptually, I assume that we are able to transform a practical time specification into lambda. Eventually, I can write, please consider lambda 1 new, lambda 2 new, and lambda 3 new, such that the control system is at least 2 times faster. In this case, of course, lambda 1 max, lambda 2, lambda 1 new, lambda 2 new, and so on, must be, if we want to do it. Let me do it so it's clear. Or 2 times lower than the original system. Let me write. So we'll clarify also this point. This is an easy formulation. I mean, when I will give you, and then I show you later how we can calculate K11, K12, and Ki. Assuming that I do a little bit more structure, but not so much. Assuming that I say, comma, please calculate the new dynamics. Therefore, the concept new, because with the controller we have a new dynamics, or the control dynamics. It's the new, but let me say new dynamics. The controlled dynamics. Such that the controlled system or dynamics is 2 times faster than the dynamics of the system. How I can solve? Or I can ask 2 times slower. Think about atom. Think about atom. 2 times slower. I can speed up the dynamics, but I can slow down. Try to do at home. And now we show you in this case, and that this is extremely easy. Answer. This is basically is in a question inside a question. This means let me organize all. Yeah, I would like to write question 8. I don't remember. Which number is the question? Because in the question inside the question, no? 8. It's here formulated in an easy form, a mathematical form. Here could be formulated as more practical. Response 8. Calculate the dominant dynamics or time constant. Dynamics. This means dominant time constant. What is the dominant time constant? You remember the definition. Is the largest one. Dominant is easy to remember. It's the largest one. This means, in our case, is the dominant lambda. We have just one because the definition is tau I, if I have more than one divided the absolute value of the real part of lambda I, excuse me. If lambda I not 0. This means for all lambda not 0. In our case, we have just one lambda. The lambda is kV divided m. I don't know if you remember. Lambda is kV divided m minus kV divided m. Because the order is 0. We cannot divide it by 0. Otherwise, the dominant is the biggest between two lambdas. Basically, as approximatively, we consider now lambda 1 news equals, for instance, 2 times this lambda lambda 2 news, for instance, 3 times this lambda, in order to obtain at least in a system 2 times faster than the original one. Remember this concept here. But of course, I can decide to say forgive lambda 1 new, lambda 2 new, and 3 news, because I can consider to skip also this consideration. But sometimes I put, in order to verify, if you remember the concept of the dominant dynamics, or the dominant time constant. Now, the new system, if lambda 1 new, lambda 2 new, lambda 3 new, the new system is controlled system, is at least 2 times faster. Assuming that I summarize the concept of the fast, or the fastness, with the dominant time constant. Because the dominant time constant would remain. Basically, this reflects approximatively. In this case, it's just 1, because 0 we cannot divide by 0. If I have a 2 constant, of course, it's an approximation, because 2 constant, they work together. Do you remember? It's the sum of 2 exponential functions. And the dominant constant reflects the rising time. Do you remember? The rising time is calculated by as much 70% of the final. This means with respect to the time constant, we can consider also equals the time constant, right? Anyways, in the definition, in any case, reflects the dominant time constant or the dominant eigenvalues, which is the smallest one, but not zero, reflect the velocity. Of course, in the exam, I can say, please slow down the system such that the new control system is at least half slower. It is easy. Instead of multiply by 2, I divide it by 2, I divide it by 3, I divide it by 4. I don't know if it's clear. It's slow. Calculations, and then we are ready. But no calculation in terms of 1 plus 2 conceptually, because we need a computer. Look, I have to calculate again K11, K12, KV. Excuse me, KI. You remember the concept to use for a given lambda. Now we have a given lambda. The idea is with MATLAB Simulink to use the concept planes. Concept related to the function plays, and then we will clarify. What is this? I will give lambda, 1 new, lambda 2 new, lambda 3 new, and then the idea is to calculate a matrix K, the row, column, the set, which is also in a matrix, which define our controller. Okay. How we can do? Look, this function here, or this matrix here, which we will call, we called A extended in the lecture. A extended because we extended the state, including this pseudo state, which is the state of the control, the integrand, but the control ends. The idea is to parameterize the problem in this form. A extended, which we know what it is, equal A augmented, we will see what it is, minus K, which we have seen that consists of 3 components, in a row which consists of 3 components. Let me say in the sense K augmented. Probably have to, yeah. No, it's okay. It's okay. Because here I consider K, now I consider K augmented, which consists of 3 elements. Now K11, K12, and Ki. At this moment, everything is consistent in the definition, which multiply B augmented. Now, what is A K augmented? A augmented. A augmented, now we'll clarify why, is A extended, but calculated at K11 equals 0, K12 equals 0, let me show you, Ki equals 0. This means without controller, because the controller here is parameterized or is expressed by the product between this vector here, row vector, and this column vector. Let me analyze this. This means I consider this matrix and I will put K1, K12, and Ki 0. Why that? Because this component here related to K11, K12, and Ki will be present here or through this difference. Let me show you what intent. I copy just putting this parameter 0. KV divided M squared. Oh, an error. Oh no. Yeah. This is not M. Please pay attention. This is not M. It's just KV. Please pay attention. Here, this is not divided M. I had the feeling that was not M. The M is just here. Look at the beginning when we build the model. Look at the beginning when we build the model. Stupid. Because this is the force, the friction force. Okay, this means here we don't have divided M. We don't have M squared. You remember this correction? Because I wrote the model without to copy without thinking in general, no? Because this reflects the friction. This means here we have KV, no? It's not a big problem here because we're working symbolically. You know? Just here, correct? Look at the original system. The original system was correctly written. This means here we don't have M squared. We cannot divide it by M squared. Please pay attention. It could happen. That is so simple. This means here is KV divided M, not M squared. Here, Ki is 0, and here we have -1, 0, 0. No? Do you remember this? What about K augmented? Easy. Because of this minus, we have K11, K12, Ki. Minus is here. Now I have to multiply by a suitable B augmented. But B augmented can be calculated, can be seen directly from here because A extended, A augmented, which is here defined in this form here, basically means when the controller is there structurally, but the parameter has it, minus this element here equals A extended. We have a constraint. This means, what is B augmented? Let me write so. If you think that this multiplied this must consider, let me say, considering basically this minus this multiplied this plus this matrix must be equal A extended, the original A extended. This means in any case here we have 1 divided M, because this row multiply this column, we will see what we have here, should complete what we had here before in A extended. K1 minus K1 divided M, minus K12 divided M, minus Ki divided M. Minus is included here. This means in any case, we have a 1 divided M. Why have here 0, 0? And the reason is extremely easy, because the controller is just in the second line. the effect of the control is just of the second line. Now, to conclude, page number 9. If you remember this important lecture dedicated to this, in which now this A look, you remember this. But this A here is a particular A. Which one? The extended. Which with the function place in MATLAB, we need this, and the vector of the new lambda. Let me do mathematically what I have to see in the exam. In the exam, you have to see, I have to see this. Lambda 1 news, which we understood what is. Lambda 2 news. 0, 0, 0. Let me calculate in a different form. Let me write lambda. Then we will put later lambda. But this will be later given. Huh? A little bit large. Let me copy. Now, we will stop here because we will obtain here a polynomial of order 3 and we can obtain 3 equations with 3 unknown once we give the 3 new lambda lambda. Of course, it's quite boring. This means using place of MATLAB, we can solve this algebraic equation. This means, let me write before, implies 3 algebraic equations. We can solve so. Using MATLAB, we don't solve in the exam, but this is enough to indicate A augmented, comma, B augmented, and a vector V in which V consists of lambda 1 news, lambda 2 news, lambda 3 news. Basically, the function place solve this algebraic equation, three unknown, which is this one. This is the unknown. K11, K12, Ki. Because it's absolutely boring. But we did once, I think, with the MATLAB. Of course, this is basically what I want to see in the exam. Here, general lambda, no, this is better. Of course, you don't have to calculate the determinant just to indicate me this. And then to indicate the idea which we see also in the exam, now to calculate K11, K12, Ki, using the function place, which solves these three equations with three unknown. The three unknown are exactly K11, K12, Ki. Exactly what characterizes the control. The calculation should not be done. Basically, this is the idea, because this is the controlled system. Once we do this calculation, we have a polynomial order 3, it's written here. And with the polynomial order 3, once we have the specification for each lambda, we have three equations and three unknown. During the semester, I put some more explicit calculation. The three equations and three unknown was indicated. Now, with the function place, but we don't have it to use. Last exercise, and then we'll conclude. I need just 50 minutes, something like that. As I told you, I didn't ask many things about the nonlinear systems, even though we have seen, but I will give you another system. X1 derivative equals X2 multiply X1, a nonlinear system. When we have a multiplication between states, you remember, we can immediately recognize that the system is not a linear one. Let me write, then it could be that I will correct a little bit. Let me see if this makes sense. No, 1 second. It's nonlinear. Yes, we have a squared here, the product. Let me see 1 second. Yeah, let me see. For a given nonlinear system, it's nonlinear, yes, x squared, and the product. Calculate, first question is question number 9, 10? 9, I think. No? Calculate the equilibrium point. You remember the nonlinear systems are characterized by equilibrium points. Also, the linear system is characterized by one equilibrium point, 0. In particular system, the linear system. Here, it could have many equilibrium points. And try to say if the equilibrium point, if more than one. No? asymptotically stable, or unstable, or indeterminate. We can see what is the medium. Indeterminate, I will recall the theorem. Okay, calculate the equilibrium point. Response 9. What is the definition? The derivative of the states equals 0. It's intuitive, is to remember. No? Why that? Because if the equilibrium points are characterized by no changes intuitively, we can assume this is the definition. This is the definition. Equilibrium point is the point in which the system remains. Remember, I told you, remains in the state where it is. This means that this could be a possible definition which reflects what we want to find. This means if I apply this definition here, we have a 0 equal x2 of t, which multiply x1 of t plus x1 of t, 0 equals minus 8 of t. No, it's clear. This means here we can write this form. No? From here, we can see that we have x1 equals 0. If x1 equals 0 from the second one imply that x2 of t is equal to 0. No? If I put here 0, from here, x1 equals 0, right? If I put here x1 equals 0, I have x2 equals 0. And if x1 is equal to 0, so x3 is equal to 0. Right? This is one point. No? Characterized as these 3 coordinates. Let me write so. Point 1 is 0, 0, 0, right? It's easy not to see. Let me see if we have other points. Please pay attention to calculate also the equilibrium point. Sometimes it's not so easy, but in the exam I will put something easy. If I put this kind of exercise, I don't know. This is the set of possible. When we have an algebraic nonlinear system, if I put here arcotangent multiplied by sin, I can try numerically, but how many solutions I have, no, God knows. But we will see that in the exam I will show you, I will propose some possible solution. Look, from here, another idea is to have x2 of t equals minus 1. Did you agree? If x2 of t equal minus 1, we have a nevertheless 0. Did you agree? The first analysis was x1 equals 0, right? 0 equals 0. The second is x2 equal minus 1. If x2 is equal minus 1, we have here x1 equal minus 1, right? Did you agree? x2 equal minus 1 satisfies the first equation, right? If I put here minus 1, I have x1 equal minus 1 again. Please correct me if I make mistakes. x1 minus 1 means x3 equal 1, right? This means we have another point. Minus 1, comma, minus 1, 1. Please check if I made mistakes. Second. Now 2 points. Did you agree? Please correct me. Or did I make mistakes? x2 equal minus 1 it's clear that the first equation is satisfied. Because the first equation is satisfied, we have just two possibilities. One is already analyzed. No? Now, if x2 is equal minus 1, this is 0 for x is 1, but x1 can be calculated from the second one. Because if x2 is equal minus 1, I have it as x1 is equal minus 1 also. And x3 is clearly equals 1 because x1 is equal minus 1 from the first equation. We don't have other solution. Did you agree? I don't see other solution. Or at least not, let me see, isolated solution as a point, equilibrium point. And we speak about points, because trajectories, but I didn't tell you about that. We can find some, some trajectories. From here, we can see that we have an x1 of t equal minus x2 of t squared. I can say from here the x1 is equal minus x2 squared is equal 0 as a trajectory. Understand what I did? But we speak about points. I did introduce the trajectory just to extend just in a second, just to understand that x1 equal minus x2 squared says 0 equals 0. Look from here. And then we have to see if it's consistent, this is consistent with the rest. But I didn't tell you about the trajectory. Points. Could be that doesn't exist because all conditions must be satisfied. In some situation, it happens that we have not only isolated points, but also trajectories. Which in each point, it doesn't matter. In this set remains in the set. Let me forget this because I told you about the points. But just a little bit. Now, for instance, if x1 is equal minus x2 squared, and here we write exactly x2 up to 4, we have another condition here, but then we have to, for x3, but we have to see what happens here. We can see here, we write x1 equals minus x2, then here we don't have a trajectory for x2, we have a point, and then we have to recalculate, let me say, everything in the sense we have in any case just 0 again for x2 equals 0 or x1 equal minus 1. This means we don't have a trajectory in this case, we have just 2 points. But anyway, point, forget this, but think about it could be that you have a sets. Now, stable or not stable, how we can do? Write the Jacobian. The general Jacobian is this here, the derivative with respect to x1. This here with respect to x2. This here with respect to x3. Second line. This line with respect to x1. This line with respect to x2. The derivative with respect to x2. This line with respect to x3. This line with respect to x1. This line with respect to x2 is 0. This line with respect to x3 is minus 1. Let me repeat again. The Jacobian, the general Jacobian. This line with respect to x1. x2 plus 1. This line, excuse me, this line with respect to x2, x1. This line with respect to x3, 0, no? Because we don't have x. What about this line? Is the derivative of this line with respect to x1 minus 1. This line with respect to x2 is 2 times x2. The derivative in the sense, the partial derivative, you remember? Why 0? Because the second line does not depend on x3. This line with respect to x1, 2 times x1. This line with respect to x2 is 0. This line with respect to x3 is minus 1. Please calculate it, for instance, at 0, 0. 0, 0, 0. This means 1, 0, 0, minus 1, 0, 0, 0, 0, 1. The determinant of this, it's 0. I don't know if it's for math, is visible. Because we have a 2 row which is dependent. Conclusion, not possible to say if 0, 0 is stable or not stable. This means exactly the sense of indeterminate. Indeterminate. Let me show you in P2, because if the determinant is 0 means that one eigenvalue, it's 0. This means no conclusion. You remember this. But really, to do exactly what happens, I have to calculate if at least one is positive. Because if at least one is positive, I cannot say that's indeterminate. If at least one is positive, the system is unstable. Let me show you. This means apparently it seems to be indeterminate. But let me talk. This is it. We don't need to do many calculations. 1, 0, 0. Apparently, it seems to be indeterminate. But it is, no? Therefore, I told you. Because the determinant is, I don't know if you remember in math, -1 up to 2, this element here, which multiply this element, which multiply the determinant of this minus. This multiply this, minus this multiply this, 0. The rest is 0, no? Because 0, which is here, just to repeat the determinant. I don't need to calculate the rest, no? Because of these 2 0. I don't know if you remember the determinant. This means really here is the point 0, 0, 0 indeterminate, because I don't have any positive eigenvalue. I mean, if at least we have a positive eigenvalue, the point is unstable. We cannot say anything because it's 0. What happens for P2? P2 was -1, -1, 1. This means 0. Look. -2, -1, +1, 0. -1. 0. -1, -2. 0. No, excuse me, -1 plus 2. -1 plus 2. And here we have is this plus. Here we have -2, 0, -1. 2x1 was the derivative. This means -2, 0, -1. Let me check again. -2, 0, -1, because here we have a -1 multiplied 2, 0, -1 because that's not change here. Here I forgot I minus, but does not change anything. No? Yeah, I forgot minus, but does not change anything because of this here. Okay, this is enough to calculate this. No? This means this position is -1 up to 3. First row, second column, which multiply this element here. Again, this element here is here. Then I eliminate this row, this column, and this row. I have 0 again. Did you see? This multiplied this minus this multiplied this. Indeterminate. I cannot say anything about these 2 points. This means could be stable, could be unstable, could be asymptotically stable. How we can determine? Yeah, it's the second theorem of Lyapunov, which is not included in the exam. Huh? Basically means recall a little bit the Jacobian from math. Recall a little bit the determinant. The rest is basically math 1 huh? or the math 2. Determinant was done in math 1. Determinant of a matrix, math 2. Question about it. It's just a calculation, just to remember that is unstable in case at least one is positive. This means at the beginning, please pay attention. If it's 0, 1 determinant, excuse me, an eigenvalues, we have to calculate, let me say, please, I made mistakes probably. Yeah, stupid. I'm a little bit tired, excuse me. The determinant is 0. This was the first example, no? I cannot say, a little bit tired, excuse me again. Let me redo the exercise. This here. Determinant is 0, but this does not say anything. Says just one eigenvalue is 0. But I have to calculate the other one. This means I have to calculate this. Excuse me, I'm a little bit stupid. Tired, as I say. Okay, this says, excuse me for the error, this says that one eigenvalues is 0. In fact, we can see. We can see this, the one eigenvalue is 0. Because what is here the calculation of these eigenvalues? This is the determinant. You remember, I consider this, which is here, multiplied by -1 up to 2, and then I consider this, multiply this, minus this, multiply this. We can see that one eigenvalue is positive. 1 is 0, we knew from determinant equals 0. But here means the system is, the point is unstable, excuse me. I'm tired here. Is unstable. Because at least 1 is positive. Of course, we have 1, 0. But we cannot conclude this in the indeterminate because the theorem says is enough one eigenvalue is positive. No? Excuse me for the error. No? I'm a little bit tired. Okay. What happens here? I have to do the same calculations. This means I have to say what happens for the eigenvalue, but it's not so difficult, no? Because it's -1, 0, 0. Yeah, it was plus. No? Yeah, here is plus. because determinant of lambda I minus 1, no? This is the idea. Determinant of lambda I minus yacht, in this case, j, equals 0. This means lambda, this was minus becomes plus, because it's minus j. Here we have minus 1 becomes plus 1. Yeah. Lambda minus 2, because you have a plus 2. Here we have a minus 2 become plus 2. Why plus? Because of this minus, no? Here 0, and here lambda plus 1. Yeah. Try to do at home, no? That we have to calculate a little bit, is more complicated because we have, let me say, 2 elements. What we have here, 0, no? Yeah. But it's not so extreme. If you want, I do it. I need another page. This is the page number 12. Determinant of this. With respect to this is lambda, again, minus 1 up to 2, which I don't need to put it. This multiply this. I hope no mistakes in the sign. It's okay. Yeah. Plus, with respect to this one, we have minus 1 up to 3. This position is odd, no? One row and second column. Minus 1 up to 1 plus 2, which multiply 1, just to understand, no? This here. And then I have to cancel this column and this row. Right? Then I have this multiplied this minus this multiplied this, which is lambda plus 1. I cancel this, and then I do this, multiply this with this one, minus this, multiply this with 0. This means I can write lambda, which multiply lambda minus 2 minus 1, because lambda plus 1 I can put here. No? We have a lambda plus 1 here, lambda plus 1 here. We have a minus 1. This means here we have a solution which is negative, no problems. Let me say here. I don't know if you remember Cartesian rules. We have at least one solution with the real part positive. This means unstable. I show you. Let me show you. Lambda 1, 2. PQ formula or the ABC formula. We can see from here. We can see. I think, with the PQ formula, I use the ABC formula. No? This means 1 plus minus root of A divided 2. This means lambda 1, 2 equal 1 plus minus root of 2, I think, no? This implies lambda 1 equals 1 plus root of 2, lambda 2, 1 minus root of 2. This is positive. This is negative, but this is positive. Imply unstable. Unstable. Equilibrium. Okay. ready. I went tired out at the end, but believe me, will be easy, will be reachable. No? Try to reconsider, nevertheless, not only what I told you today, from the beginning, in my study, the YouTube, if you until excluding the topic of which we have seen yesterday and the last part of before last week. This means it could be that I will ask a very easy equilibrium point, very easy, not so complex, to classify. Could be, but could not be. And second Lyapunov theorem, which we have seen detail yesterday, absolutely not, because at the end we cannot ask something which is the last for lecture, which is a recovered lecture outside the time. But please reconsider everything, also electrical systems. Once the model is done, everything does not change. Question?
Can you tell us roughly how many constituents that would be like 5 or 6 or like 10?
You can realize that we have a main question and then some questions. But believe me, I have already a scheme in which the majority, all or almost all students were able to pass the exam. This means statistically, if you attended the class during the semester, not only today, but also in this case, if this week you are able to reconsider not only this, everything, with the help also the YouTube, I'm sure that the lecture is not particularly because I try to simplify, but in any case, everything which we can consider that could appear is exactly what I told you. You will realize that you can recognize everything which we did together. Consisted again on the number of questions. Sometimes, if you consider, for instance, please indicate the states and justify the indication of the choice. It's of course two questions, but basically in 1 second you say position, velocity, or voltage and current because we have two energy. How much? Of course, how much time do you need? I don't know, 30 seconds to write. Also, we define to say kinetic energy. Today we have seen X1 around work, X2, no, it's zeta2 around kinetic energy. So in two questions, but then we have a more structured question, but you have seen, but redo everything which you find in my step. You cannot fail. And about the equilibrium point, if I put extremely easy. Not three equilibrium system of three equations, but probably two. One doesn't make much sense. I mean, it made sense, but we tried to do. You remember at the beginning when I introduced with the system of two states, if I remember well. Now I extended three, but I don't put three. I will put eventually. If I put just two states, this means the calculation is reduced a lot. Because the determinant with matrix 2 times 2 is intuitive. This multiply this minus this multiply this is all defined. Here, just to show you why this example, because in practical application, it's not the exam again. Second order is very often. Therefore, is more the idea of second order, but also order 3 because you have problem of chaotical systems, but it's not, again, don't wait. Eventually, if I put the equilibrium point with 3 state, eventually too. Let me say you good luck. Good luck to everybody. I am not sure if I will be present on Friday because it could be that I have to travel. But you will recognize no surprise. You will not be disappointed, I hope. No, don't bring any material. We'll give you the data sheet in which you can find the equations and what you need to be applied.
So we need no calculator.
Calculator, yes. It could be that you can use, but you can see that you can sketch directly the solution. could be that it could be useful sometimes to verify calculator, of course, but no material from the lecture, or no your notes. Because anyway, this is standard. You will see the standard. Thank you. Good luck, no?